I was speaking on mute. Can you hear me
Ah,
now?
yeah, there you are. Good.
Amazing how much better that works. All right, so let me share my screen. What I'm going to talk about is essentially um, the highest level of data architecture. So if you're trying to form a data architecture to get analytics to the people who need it, so that they can then use it to make decisions. You can use, you can use that information to drive artificial intelligence machines. You can use it for a lot of things, but first you have to get that data to where it needs to go. You have to get it crunched, you have to get it combined, you have to get it analyzed, and that's pretty much what I'm going to talk about. So one of the things I'm going to look at is some of the architectures that exist, and how some of those are sort of morphing over time. And then I'm going to look at, it's more of a generic kind of look at what did we have in the past, what did we have next, and then kind of, where I think we're going from here. So that's the general idea. All right, so let's kind of look at this. First off, I think one of the questions a lot of people seem to have in their brain is, or one of the misconceptions I think that a lot of people have is that IoT is coming, that it's a thing that will come in the future, but isn't quite here yet. And I think that's very inaccurate. There are a lot of people doing very high scale analytics, including analytics that comes from machines, from the industrial Internet of Things that previous speaker was talking about. A lot of that is happening in your day-to-day life. It's touching you every day when you dial Uber to bring you a food delivery, or before the COVID craziness, to bring you a car to go somewhere. The Cerner Millennium is using this kind of geometric information about where a doctor is, what they've done, how that's working, to over time look at patient outcomes and improve patient care. So that's huge, especially right now. Train is making sure that your building that you're working in, assuming that you were working in a building and not at home, would be comfortable all the time without costing the company a huge amount of money. If you got to do your taxes online, which almost everyone does now, Intuit is optimizing their softwares to make that as easy as possible for you to do. So everything from optimizing network for telecoms so that your calls don't drop, to optimizing routes for buses so that there's fewer accidents, to optimizing manufacturing machines. This is every day this happens. We have Climate Corporation is optimizing crop yields for farmers with software in their tractors. It's like this is not a future thing. This is definitely happening. So let's talk a little bit about how that looks. So in production, this is almost always how it looks. And this one is from Phillips. Phillips builds medical machines like MRIs and things like that. Every component they build has in it essentially a sensor or a call home device that says, here's how I'm doing right now. And that information is a massive amount of time series information that gets brought in and put in some sort of mass storage. And it gets combined with a lot of relational database information and geographic information and other information from out in the world. And all of that combined together is then used to train models, usually machine learning models, so that you can figure out something interesting, in this case, the pattern that a particular component makes when it's about to break. So you want to know what that pattern is before it breaks. So instead of having the machine break down and being down for a while, maybe it's an essential MRI machine that people need, you don't want that down for weeks while someone tries to figure out what's wrong with it, while you call a repairman, while you go, is this the right part? No, that's not the right part. Let me order the other part from the warehouse. Oh, okay, I think this is the part. It's like, instead, that machine learning now monitors that incoming information from every single component from every machine they've made and says, oh, there's the pattern. This part in this particular machine in this particular hospital is about to break. Let's schedule somebody to go out there and fix it before it breaks. So that's a really good example of how this works. You have a batch kind of thing where you have streaming data coming in, but it's accumulating over time into a large amount, and it's getting combined with a lot of contextual data. That's used to train your models. And then in real time, you have the streaming information coming in from your devices. And you're using that and the model to identify something in real time and do something about it. Now that's pretty much high level what happens every time. So let's look at specifics. Let's dive down. I'm going to start with Phillips because that's the one I used for the example, so that seems appropriate. So Phillips, this is kind of their high level of their network. Now I'm not going into the edge just because a lot of that is covered in other presentations and things like that. And a lot of that is going to be essentially just taking the information that says everything is fine, everything is fine, everything is fine. Oh, I changed by a tiny bit. And only sending this stuff that's information. So it's like I got 25 things that said, 14 degrees, and then I got one that says 14.1 degrees. It's like, okay, I'll just send two things, one that says 14 times 14, that was confusing, but you get the idea. So you consolidate it with the edge so that the only thing you send to the central repository is what is important. And then sometimes you will take your model and then put it closer to the edge so that as you get that immediate information, you maybe can act in on it right there. But a lot of the real action is going to happen in your central analytics. So that's what this architecture is about. They have the phone home system that they built themselves in this case. That's pretty unusual, but Philips has been doing this for like 100 years. So they kind of have a lot of experience with this, more than I think most people in the market. And they're taking all of their other information and they're doing the ETL with Java, putting it on IBM Spectrum Scale and some Isilon attached storage. IBM Spectrum Scale is essentially IBM's answer to Hadoop. So there's your mass storage, and that's where they put everything, and that's where they do most of the work. They use Java then to pull it into the data that's all combined and happy and good to go into their analytics database. Now this is a distributed analytics database, so it's going to be able to scale up as big as it needs to be. And the cool thing about this is they're then taking Python and R and they're putting it into the database, which automatically distributes it to make it more efficient over that large database. And then they're using that to power both their BI visualizations and their data science and their machine learning and things like that. So that kind of gives you a general idea. I think this is a pretty typical architecture in some ways, and in other ways it's very unusual because they built a lot of things themselves. And that's not the way a lot of people do it. A lot of people use Hadoop. So let's kind of look at that. In this case, this is on Ritsu. They do analytics for telecom industry. They actually do it for a large international telecom industry. They create analytics and they sell it, and they sell machine learning and they sell BI both. This kind of gives you an idea of how they're doing it. And again, they're pulling everything into a mass storage, HDFS in this case. They're using MapReduce to do a lot of that ETL where they're combining it. They're putting it in Hive, and that's where their cold data stays. Their hot data they're using to pull into their distributed database. Now they're using drill to do some exploration so they know what it is they want to pull into the Hive, the important things. It's like, I know what my data is, now I'm going to do something cool with it. And then they're using Spark and Hive to kind of move it over and to keep it in sync so that the analytical database and the Hive store don't get out of sync. And that's how they power the thing. So okay, that's kind of an evolution, and we're kind of seeing over time, we're seeing a little bit. So obviously a lot of people are wanting to move to the cloud and do things like that. So this is, I think, one of the more interesting ones. We're starting to use Kafka. to get more inline information. We're starting to get a little higher speed. This is simplified. They are actually doing sub-second response. So they are getting real-time bidding coming in on an ad space on a page. So if you click on a page and it comes up within a second or two, in that second or two, they've gotten bidding information. They've pulled information about everything they know about you, about your browsing history and things like. They know you browsed that fishing boat last week, and now they're going to sell that ad space to somebody who wants to advertise a fishing reel, maybe, and they're gonna get that bid immediately and address that quickly within a second at the most. And that's a pretty impressive capability, but they have to have gathered over time. They have to have gotten a lot of information and created their patterns so that they know what to do at that final moment. And one of the things they're doing is they're putting pretty much all of their data into a distributed analytics database at high granularity. They're not really doing a lot of aggregation. And that's what they're using for that real-time bidding thing. Well, but then they also need to do normal BI like everybody else does, but on aggregated smaller data. So they're creating another database, another cluster to do that. And then of course their executives want only the highest level. So they're creating another cluster. Now this is an interesting thing that I'm seeing more and more is the need to isolate workloads. So we have the machine learning workload on one cluster, then you have the standard data-driven BI that you think of on the other cluster, and then you have the high-level executive view in yet another cluster. And the advantage of having 3 different clusters is that you get workload isolation. It's like there's no chance that an executive drilling down on his dashboard is going to slow down your machine learning. It's going to keep your page load from being fast enough to get that ad in there before somebody clicks to the next page. The disadvantage is they're going to have to do ETL each time and keep all 3 of these subclusters in sync. So I think that's something that you're seeing more and more of. In fact, Uber is doing a lot of this on Amazon Cloud. They're doing some of it on-prem, but they're doing it at unbelievable scales. They are doing this 100 petabytes or more data because they have so much coming in. Now they're pulling it into HDFS. Instead of using MapReduce, they're using Spark to do their ETL. Instead of using Hive, they're using Parquet to put their clean, process data in. They're using Spark to put it over into the distributed analytic database. They're also doing a fair amount of data science and things like that using Hive and Spark and Presto, Jupyter Notebooks, all that sort of thing. But a lot of that is done in those databases, some of the data science experiments, CityOps, things like that, and their BI and stuff. And again, to avoid interfering with each other, they've created multiple clusters. In order to keep track of where everything is, they've had to write their own data manager and a proxy to say, okay, this is where everything is. So if I send a query, it goes to the right place. So that's kind of a workaround to make something work. And I think as we keep going, Climate Corp is doing this entirely on the web. Now, one of the things that I want to point out in this is that they are doing some of their data science in Spark and some of it in the analytics database. And they're using Domino Data Lab to manage those. So you have 2 different teams, both trying to accomplish the same thing. They've got to manage the models, they got to keep track of who's doing what and where and all of that. So that is really helpful to get one central location where you're managing both workloads and both teams, and it can be multiple teams. Now, the cool thing about United Group, they're a young company that's really, they're not that young, but they're growing really fast in Eastern Europe, and they're swallowing up other companies. Now, this is only part of their architecture. What I want to point out here is, if you just looked at this, you would say, That's a data warehouse architecture. If you've been in this for a while, you're going to look at that and you're going to go, that's a data warehouse architecture. You have all of these sort of batch information coming in. You have Informatica doing some ETL. They're pushing some of it down into the database, but it's not that different from what we've been doing for 20 or 30 years. So this is not that big a deal. So now we're doing some business intelligence. What's cool about it? They are also pulling in set-top information, combining it with that batch information like the TV schedule and things like that. And now they can figure out that the two people next door to each other, one of them is a young man who's single and the other is a 35-year-old housewife with 2 kids. And they know that based on what they watch on TV and what time they watch and things like that. So now I'm Gillette. I want to send an ad. And I have one with a manly man shaving his face. And I have one with a girl wearing short shorts and shiny legs. Which one do I show? Well, they now can do the same kind of real-time ad targeting that before was only possible on a website. Now they can do it on TV because they have added that real-time capability, and because they have all that information about who is watching what, they can send the right ad to the right person. And I don't know how some people feel about that they're frustrated that fishing boat follows them around all over the web, but I think it's better than getting ads that have nothing to do with your life. You know, I don't really want an ad for Preparation H or whatever. It's like I'd rather have something that actually is relevant to me, but that's sort of my preference. And I think this is where the world is going. So this is a trade desk. They are also working at petabyte scale. Each of those subclusters has 320 nodes, and they're doing it all on a single cloud. Now that's one way that people are going is sort of one cloud, everything. But some people are sort of working their way towards multi-cloud. You're getting hybrid and things like that. But one of the big cool things you're getting is this subcluster concept. It gives you some of that advantage of having multiple clusters. You get workload isolation. You don't bump into each other. But it's all managed within the database so that it doesn't, you don't have to build your own proxy. You don't have to build your own manager and things like that. It's all taken care of. And your mass storage is actually taking advantage of the, gotcha, 10 minutes. It's taking advantage of the cloud storage, which is very elastic and has a lot of space for you to play with. So you get the capabilities of the mass storage and the capabilities of the database, and they've kind of like glommed together. They become almost merged into one thing in that case. So you have all the abilities of Hadoop, of S3, of that sort of thing. And in this case, they're actually spinning up 3 clusters because they need to do about 5,000 daily reports. So 2 of those clusters are just doing all those reports. And then when they're done, they shut down. Because that's a massive amount of compute they're paying for, and they only have to pay for it when they're using it. And they know it will not interfere at any point with their other cluster, which is doing their machine learning and their BI and their, their data ingestion and ETL and things like that. All the other things that a database needs to do in this case. So that's, I think, some of the things you got to look at. Those are all highly successful in production architectures. They are all working. So what's cool about them? Well, they're all fairly simple in design. They all have that low latency streaming high speed kind of thing, and they have a historical batch processing and the need to combine them at some point. They all, to a certain extent, as much as possible, they bring the analytics to the data. They don't pick the data up and go take it to where the analytics is. So that's, I think, 3 really important principles. And I want to kind of look at this. So this is data warehouse architecture. Everybody's familiar with this.
Yeah, it's about 4 minutes till questions.
I gotcha. So this is kind of what we've seen over time. And then this has been here around a long time. This has been working for us for BI and things like that, but it couldn't handle the crazy kinds of data that we have nowadays, the IoT data, the sensor data, the time series data, all that kind of thing. And it couldn't do machine learning. It couldn't do data science. It couldn't do the more sophisticated types of analytics. So we thought, well, data lake, that's the solution. It has all this mass storage. It can handle streaming data coming in. We can combine it. And then we'll put a query engine on top of it, and that'll solve everything. Not so much, but you kind of got the idea that this was gonna replace what we had before. But that's not really what happened. What really happened is people started combining them because there were strengths in both. And that cooperative architecture is really what you see a lot of in the guys that have been in production for many years. Now, what you see moving forward is more of that, here's my data lake, here's my data warehouse. They've sort of squished together into one giant thing, where I also have the capability to do subclustering for workload isolation. And I can manage my models in there, and I can do data science in there. I can use Jupyter and Python and R and things like that. But I can also, I can do my BI, my reporting. I can use Tableau and BI and Cognos and things like that on top of it. And I can store all of the data I want to store. I can do it on premises, on HDFS, or I can do it on the cloud in S3 or Google or whatever, or multiple clouds or hybrid or however I want to do that. And this is, I think, the wave of the future. This is where we're going. Unified Analytics Warehouse. And I've heard it called other things, but I prefer that one. Thank you. So takeaways. Is the takeaway the Unified Analytics Warehouse is the way to go? It's going to be the way of the future. No. Takeaway is don't lock yourself in. The only standard in this industry is change. It changes constantly. Be sure that whatever choice you make today does not mess you up later. Defofu is the acronym for that. Don't commit to only open source or only proprietary or only one brand. Don't lock yourself into only one deployment option on-prem, on this cloud, on that cloud. Multi-cloud, hybrid, that's really kind of where things are going, and things change. It's like cloud may be the thing today, and then tomorrow it may not be the thing, and now I got to move back to on-prem. And if I've locked myself in to one or the other, I might be in trouble. So Defofu stands for don't F over future you. Keep that one in mind. That's probably the most important architectural principle you can remember as we go along. So, all right, I am ready for questions. If you want to hit me with some.
Thank you, Paige. Oh, there's one just popped up. Can you see it on the bottom?
Hang on
There's
a second.
Are companies developing this architecture from in-house or working with outside groups to build these systems? And
yes.
I mean, you come from Vertica.
I work from Vertica. I work for Vertica now. I don't know if I come from Vertica. I have worked at Pervasive, Data Junction, Actian, Hortonworks, the Blur Group as an industry analyst. I did some independence consulting. I worked for CSC. I've done a lot of different things, which I think my intro kind of starts with. Nowadays, I am working for Vertica. Is that the question? Does that answer?
Well, the question was the lovely blue integrated database at the back end of each of your diagrams. Is that related to Vertica?